The universe is a strange and wondrous place, and the deeper we peer into its depths, the stranger it becomes. The James Webb Space Telescope, humanity's most advanced eye on the cosmos, has been delivering jaw-dropping discoveries since its launch in December 2021, and now its latest findings are shaking the very foundations of what we thought we knew about reality itself. Scientists are staring at images that don't make sense, objects that defy logic, and phenomena that challenge the rules of physics as we understand them. Nobel Prize-winning physicists, the very architects of modern cosmology, are sounding the alarm. They warn that what Webb is detecting may point to something far beyond our current understanding, perhaps even another universe entirely. What we're about to explore is a cosmic mystery leaving astronomers baffled, one that could rewrite the story of everything. Let's begin with the big picture. For decades, scientists have relied on the lambda cold dark matter model, the standard framework of cosmology. This model tells us the universe began 13.8 billion years ago with the Big Bang, a moment when all matter and energy erupted into existence, setting the stage for the formation of stars, galaxies, and everything we see. The lambda CDM model assumes a universe dominated by cold, dark matter, an invisible substance that helps galaxies form, and dark energy, a mysterious force pushing the universe's expansion to accelerate. It's a model that has served as the foundation of cosmology for generations, helping scientists understand how the cosmos evolved from a hot, dense soup to the vast web of galaxies we observe today. But Webb is throwing a cosmic wrench into that tidy narrative. With its advanced infrared capabilities, the telescope can peer farther back in time than any instrument before it. And what it's seeing is deeply unexpected. Among the biggest surprises, galaxies that are too massive, too bright, and too well-organized for their age. These aren't the dim, chaotic clusters of stars we expected to find in the early universe, mere hundreds of millions of years after the Big Bang. Instead, Webb has uncovered galaxies that are already mature, bursting with stars and glowing with an intensity that shouldn't yet exist. In one 2023 study published in the Astrophysical Journal, researchers identified 87 candidate galaxies that may have existed just 200 to 400 million years after the Big Bang. According to the lambda CDM model, that's far too early for complex galactic structures to have formed. These galaxies are so massive and luminous that they seem to break the rules. There simply shouldn't have been enough ordinary matter in the early universe to form them. For these enormous galaxies to exist so soon, almost all available matter would have had to collapse into stars immediately, a process that contradicts known physics. Let's unpack that. In this standard model of galaxy formation, matter collects gradually. Gas and dust coalesce under gravity, slowly forming stars over millions or even billions of years. Typically, only about 10% of a galaxy's gas becomes stars, with the rest lingering as dust or unused gas. But the galaxy's Webb is seeing appear to have converted nearly all of their gas, nearly 100%, into stars. Spectroscopic analyses reveal little to no dust or leftover gas in these galaxies. What remains is pure stellar mass, shining brightly. This rapid, complete star formation isn't just surprising, it's unheard of. Imagine walking into a brand new town and finding a fully constructed skyscraper on day one. That's what these galaxies represent. The timeline just doesn't make sense. How could these galaxies form so quickly, and why do they look nothing like our predictions? These questions are now being raised by some of the most respected voices in astrophysics. Physicists like Adam Rees, who received the Nobel Prize in 2011 for work on the accelerating expansion of the universe, have expressed deep concern about the implications of Webb's data. Rees, in a 2019 lecture at the Kavli Institute for Theoretical Physics, described growing inconsistencies in the expansion rate of the universe as a crisis. Webb's observations have only added urgency to that sentiment. These early, massive galaxies don't fit into the narrative of a 13.8 billion-year-old universe. Their very existence may suggest the cosmos is older than we thought, or that the Big Bang itself isn't the absolute beginning of time. We understand it. So let's talk about that Big Bang. Many of us imagine it as a single explosion, a sudden spark of creation, but the event wasn't localized. It happened everywhere at once, a simultaneous transformation of the entire cosmos from an unimaginably hot, dense state into the expanding universe we see today, the cosmic microwave. Background CMB, a faint glow we detect from all directions, is the leftover heat from that era. This ancient radiation is the oldest light in the universe, a sort of baby photo of the cosmos from when it was just 388,000 years old. But Webb is looking even further back into the era before the first stars formed, a period known as the Cosmic Dark Ages. What it's seeing doesn't match the expectations set by the CMB. Instead of primitive, barely formed structures, Webb is revealing enormous galaxies, what some astronomers have dubbed red monsters. These galaxies appear bright red in infrared due to their dust content, and they're staggeringly large for their age. In July 2025, a post on X by Constructivism highlighted the discovery of 3 supermassive galaxies existing within the first billion years after the Big Bang, nicknamed red monsters. These galaxies are so massive and luminous that they contradict everything our standard models predict. Even more unsettling, they're not chaotic or irregular. They're highly structured to organized to have formed so early. Unless we're missing something big. This leads some scientists to question whether these objects are even galaxies as we define them. Could they be an entirely new kind of cosmic structure? If they are galaxies, they challenge the entire timeline of cosmic evolution. If they're not, then we may be on the brink of discovering a new class of objects and possibly a new branch of physics. In June 2025, NASA Goddard posted about the AELS 1963 cluster, another example of massive, star-packed galaxies already flourishing just 200 million years after the Big Bang. Either something allowed galaxies to form at breakneck speed, or the universe is older than we think. Or perhaps these aren't galaxies at all. Whatever the case, the implications are staggering. Now, let's dive into a truly mind-bending idea. What if the Big Bang wasn't the beginning? Some physicists are questioning whether it marked the actual start of everything. Webb's discovery of a possible preferred direction in galactic rotation adds fuel to this fire. A March 2025 article on Space.com reported that Webb observed 263 galaxies as part of the JADE survey. Surprisingly, about 2/3 of those galaxies rotate clockwise, while the rest rotate counterclockwise. In a truly random, isotropic universe, this asymmetry shouldn't exist. It suggests a preferred direction, a possible remnant of a larger structure, or perhaps apparent reality. One radical theory proposes that our universe is the interior of a rotating black hole. If true, this means our cosmos could be a bubble. In a much larger reality, the idea sounds like science fiction, but it's gaining attention. The implications are staggering. Everything we know might exist within a much grander framework we've only begun to glimpse. Let's now step back and consider the Hubble sphere, the theoretical boundary beyond which galaxies are receding faster than the speed of light due to the universe's expansion. You'd think we couldn't see past it. But thanks to dark energy and the stretching of space itself, light from even those receding galaxies can still reach us. The result, Webb is capturing images from a time when the universe was still an infant. Take the galaxy JADE's GSE-14. Webb observed it as it was just 290 million years after the Big Bang. That light has traveled 13.5 billion years to reach us. But the galaxy itself is now far beyond our observable universe, lost past the cosmic horizon. Its current state is something we'll never witness. This accelerating expansion was first revealed in 1929 when Edwin Hubble discovered that galaxies are moving away from each other, their light shifting redward with distance. But Webb's new measurements of the Hubble constant, the rate of this expansion, aren't lining up with previous estimates. A March 2020 for LiveScience.com article reported a confirmed discrepancy between Webb and Hubble data measurements from Kified variable stars point to a faster expansion rate than expected. Adam Rees once again called this a real and exciting sign that we may have misunderstood something fundamental about the universe. Then there's the mystery of the little red dots. In December 2022, Webb spotted a new class of compact red-hued objects dating to the first 1.5 billion years after the Big Bang. Described in a March 2025 Newsweek article, these objects appear to host supermassive black holes that are still growing. They're too small, too bright, and too dense for their age. Astrophysicist Dale Kuchevsky noted that they resemble nothing seen closer to us. Could they be baby galaxies with massive black holes at their centers? Or are they something else entirely? Webb's findings also shed light on our own galaxy. Observations of Sagittarius *, the supermassive black hole at the center of the Milky Way, show it flaring with unexpected bursts of energy. If early black holes behaved similarly, they could have accelerated the formation of those massive, mysterious galaxies Webb is spotting in deep space.